It's definitely the late crowd. Yes. Yeah. So basically, loving all the gooning. What? What is that? What is that? So it is actually a favorite topic of mine to look at dark matter from various approaches. And if you look at it from an astrophysics point of view, so this is one way of explaining it. Basically, if somebody were to research dark matter within, say, our own galaxy or in our nearby galaxies, then that's sort of an astrophysics or astronomy approach. But if you were to think about dark matter as it affects how our universe has evolved, how it affects large scale structure, because we also looked at how the distribution, so get this, the distribution of galaxies in our universe is not random. The universe not only evolved from a baby universe to the way it is now, it has gone through evolutions, it has gone through stages. It used to be radiation dominated, then it became matter dominated. Now it's like dark energy dominated. But also the distribution of galaxies, which is something we can like measure, in the universe is not random. There is a meaning to this madness. And so I feel that some people probably study dark matter just in the context of how it affects large scale structure. And that is a cosmology approach to dark matter. So if you're doing that, then congrats. I think that's really cool, and continue on. And yeah, this type of live stream is hopefully helpful for things like that. The universe is nothing but random. You are nothing but random. Don't you dare. Don't you dare. We're having a serious conversation. Don't interrupt with your whatever it is. The distribution of the universe's mass is maybe the key to figuring out. So that's what I'm saying. There are multi-pronged approaches to figuring out what dark matter is. It's a multi-pronged approach, right? You can look at it in terms of effects on our own galaxy. You can look at it in terms of effects on our neighboring galaxies. Or you could literally try to figure out why our universe's distribution is the way it is in terms of the galaxies. And of course, all the galaxies, all of us, we are all made of ordinary matter. The stuff that gives luminosities for us to pick up on, the stuff that interacts with light, so we can measure it with light. And then there's, of course, other ways of measuring things too, like for example with gravitation, and we did that, and that's how we know that there is dark matter. Exactly. So because we want to know how the universe works. Exactly. So I've never understood the practicality. Well, astrophysics is not practical. Generally speaking, astrophysics, cosmology, astronomy, we don't have the burden of being practical. We have a privilege, which is that we can think and do cool things without being useful to anybody. Now we will talk about neutron stars, another useless thing, but lovely thing, just amazing thing. What happens to stars whose initial mass is greater than 7 solar masses? Amazing. There aren't many stars that massive. Well, keep the live chat engaged. Thank you so much. What happens to stars whose initial mass is greater than 7 solar masses? That's 7 suns, guys. Our sun, 7 of them. There aren't many stars that massive, but they do exist. I have no idea. I have thoughts about dark matter, but I do not know what is gooning.